In this video, we're going to talk about angles. Angles are an important part of trigonometry, so we're going to start with some basic definitions and notation dealing with them. So an angle is measured from an initial side to a terminal side, like I have drawn right here, and if we measure in a counterclockwise way, then that angle is going to be positive. So in this example, from this initial side to this terminal side, we might have an angle of about, say, 30 degrees. On the other hand, if we measure from the initial side to the terminal side in a clockwise manner, then our angle is negative. So in this case, our angle might be negative 30 degrees. Okay, so I just used degrees as a measurement, so let's talk about what a degree is. So the way that we measure degrees is that a full rotation, one full rotation, like you would do, say, on a snowboard or a skateboard, is 360 degrees. Then 1 degree is going to be 1/360th of a rotation. Okay? And 180 degrees would be 180 divided by 360, or half a rotation. So something like this. Okay? And 90 degrees would be 90 divided by 360, or 1/4 of a rotation. Now 1/4 of a rotation is going to look like this, a quarter of a turn. Okay? So something like that, 90 degrees. Okay, so we have a lot of different types of angles, but these major types that you might have seen in a geometry class are acute, right, obtuse, and straight. So an acute angle is an angle which is between 0 and 90 degrees. Okay? So it's less than a quarter of a turn. Okay, you can think of this as a small little angle. Okay, so theta, so in this case, theta is about, say, 30 degrees, maybe 45 degrees. Okay? A right angle is 90 degrees. Right? So 90 degrees is, again, a quarter of a rotation. Okay? You might have heard the terminology perpendicular, that these two lines are now perpendicular. And to denote that, a 90-degree angle, we're going to draw on a square little box right here, just to denote that it is a perfect 90-degree angle. An obtuse angle is an angle which is bigger than 90 degrees, but less than 180 degrees. So more than a quarter of a turn, but less than half of a turn. So something like this. Okay. So this angle right here is about, let's say, 120 degrees. Again, it's somewhere between 90 and 180, so we call that obtuse. Right. A straight angle is exactly 180 degrees. Right. So it's a half of a turn, and if you look at a straight angle here, then it makes a straight line, okay, which is why we call it a straight angle. Okay. All right. So next terminology that we're going to use, and we're going to use this quite a bit throughout the rest of this class, is complements and supplements. So we say that two positive angles are complementary, or complements, if they sum to 90 degrees. And two positive angles are supplementary, or supplements, if they sum to 180 degrees. So for example, 30 and 60 are complements because 30 plus 60 is equal to 90 degrees. And this little circle up here is the degree symbol. Okay? So it is going to be important. Later on, we're also going to do measurements in something called radians. So we want to make sure that we put these degrees when we are talking in degrees. Okay? And our other part of this example is that 60 and 120 are supplements, because if we add those together, we get 180 degrees. Okay? And again, that's just the definition of complements and supplements. Okay. All right, so let's look at an example. Okay, you'll see one like this. So if theta is equal to 55 degrees, find its complement and find its supplements. Okay. So for its complement, which I'll label C here, we know that complements add up to 55 degrees. So if we do add up to 9 degrees. So if we take 55 degrees plus its complement, it has to equal to 90 degrees. Now this is a pretty easy equation to solve. All we have to do is subtract 55 from both sides, and 90 minus 55 is 35 degrees. So its complement is 35 degrees. Okay. For its supplement, okay, we do the same thing. That 55 degrees plus its supplement has to add up to 180 degrees. Okay. So again, solving in a very similar manner, just subtracting that 55 from both sides. Okay. We're going to get 125. Okay. So its supplement is 125 degrees. Okay. All right, so let's look at another problem dealing with complements, but written slightly differently. So here we have an angle B, which is equal to 2x degrees, and A, which is equal to 3x degrees. And we want to find what A and B are exactly. Right? So how do we do this? Well, notice that this little squared off region right here show that these two angles add up to 90 degrees. Again, this is the notation for a right angle or 90 degrees. So i.e. A and B are complements. Okay. So if we add them together, again, we should get 90 degrees. So A plus B equals to 90 degrees. And now we use the fact that A is equal to 3x and B is equal to 2x degrees. Okay, and we solve this equation. So 3x plus 2x is 5x. So we get 5x is equal to 90 degrees. Or x is equal to 90 divided by 5, which is 18 degrees. Okay. Now that doesn't answer the question, because the question didn't ask about x. It asked what A is and what B is. So in this case, A is equal to 3x, or 3 times 18 degrees, which is 54 degrees. Okay. And B is 2 times 18 degrees, which is 36 degrees. Okay. And we can verify that these are complementary angles by adding them together. And again, if you add 54 plus 36, you're going to get 90 degrees. So they are, in fact, complements, and we did this correctly. Okay. All right, so another notation that we're going to use besides degrees is to narrow it down a little bit more. We can use minutes and seconds. Okay. And this notation is very similar to minutes and seconds in the real world. So minutes is 1/60th of an hour. So here, 1 minute is going to be 1/60th of a degree. And we use this notation of a 1 with this little prime, it's called a prime symbol right here, is equal to 1/60th of a degree. Okay? And 1 second, which we use 2 prime symbols here, okay? 1 second is 1/60th of a minute. Okay? So 1 second is 1 minute divided by 60. And if we wanted to go all the way to degrees, it's 1/3600th of a degree. And 3600 is just 60 times 60. Okay, so the way that we use this notation is we first put the degree, then we put the minute, then we put the second. So something like this would be read 10 degrees, 11 minutes, and 20 seconds. Okay. So adding and subtracting with minutes and seconds. So all we have to do here is combine like terms, and we might have to round up. Okay, so for example, if we want to add 22 degrees, 18 minutes, and 11 seconds to 10 degrees, 52 minutes, and 5 seconds, let's line this up in columns. Okay, so I'm going to put the minutes on top of the minutes, the seconds on top of the seconds, degrees on top of the degrees. And we want to start over here on the right, okay? And 11 plus 5 is 16 seconds. Okay? 18 plus 50 is 70, so 70 minutes. And 22 plus 10 is 32 degrees. Okay? Now, just like you wouldn't say it's 1 o'clock and 70 minutes, okay, what you would do is you'd carry 60 of these minutes over, and 60 minutes would become 1 degree. So I'm going to subtract 60 from 70 and add 1 degree. So this is going to become 33 degrees. And again, it takes 60 minutes to make up that 1 degree. So I subtract 60 from 70 and I get 10 minutes left. Okay? And the 16 seconds are just left over. So overall, we have 33 degrees, 10 minutes, and 16 seconds. To do subtraction, we can do it the same way. Okay? It's going to be very similar to subtracting longhand that you do, where you might have to borrow numbers. So we want to start again on the right side, and if we subtract over here, okay, 18 minus 52 is a negative number. So what we want to do is borrow 1 degree, so 21 degrees, and that's going to add 60 minutes over here. So 60 plus 18 is 78 minutes. And that will allow our minutes to be bigger on the top so that we can actually do the subtraction. So now 78 minus 52 is going to be 26 minutes, okay? And 21 minus 10 is going to be 11 degrees. Okay? And if we added seconds to this, it'd be very similar. We would just need to add another column, and you again, when you subtract, just like you do subtraction long numbers, you want to start over on the right-hand side and slowly work your way left. Okay. All right, so conversions. So we can write with minutes, seconds, and degrees. We can also use decimals. Right? So, for example, if we want to convert 10 degrees, 11 minutes, and 15 seconds into decimals, what we do is take 10 degrees plus 11 minutes, okay, turns into 60th of a degree, okay? And then remember that seconds in degrees are 300 or 3600th, okay, of a degree, okay? This is just pure calculator work, and you can take out your calculator, okay, and add these things up, okay, which I'll do right now. And we do again 10 plus 11 60th plus 15 divided by 3600, and we get this to be 10.18. Okay, and when you do this on your calculator, you're going to get 1875, but it says to round to the nearest thousandth. Okay, so when we round this, we're going to get 10.188. We'd round up on that last digit. Okay. All right. On the other hand, if we want to convert 85.263 to degrees, minutes, and seconds, okay, well, the 85 degrees is just going to be 85 degrees. And then the 0.263 degrees, okay, the decimal part of our degrees, is going to turn into the minutes and the seconds. Okay. So the first thing that we want to do is convert this into minutes. Okay. So the way we do this is we're going to multiply by 60 minutes in every 1 degree. Okay? And then what you can think about is the degrees canceling. Okay? So what we're going to get is 0.263 times 60, or we're going to get 15.78 minutes. Okay? Again, this is going to lead to 15 minutes, okay? And then 0.78 is going to turn into seconds. Right. And again, we're going to do the same thing. We're going to multiply by 60 seconds divided by 1 minute. Okay. And again, this is just 1. 60 seconds makes up 1 minute. And we put the unit that we want to cross out on the opposite sides of the fraction so that they do. And we're going to get 0.78 times 60. And we get 46.8, which I'll round up to 47 seconds. So overall, we had a whole number of 85 degrees. Okay. Then the decimal part turned into 15.78 minutes. We took the whole part of that, 15 minutes. Okay. And then that decimal part, 0.78, turned into 47 seconds. So our answer is 85 degrees, 15 minutes, and 47 seconds. Now we can actually do this on our calculator as well, which I'll show you in a later video. So if you want to learn how to do that faster on your calculator, stay tuned for a later video on using calculators. All right, in this class we're going to do a lot of things on the XY plane. This is called the XY plane, sometimes also called rectangular coordinates or the Cartesian coordinate system. Okay. In standard position, what we're going to do is start with the positive x-axis being your initial side, and again, we're going to measure counterclockwise for positive angles. So this is your initial side, and this is your terminal side. Okay? So acute angles are going to land over here, which we call the first quadrant. Okay? A 9-degree angle is going to be right here, again a quarter of a rotation. Obtuse angles are going to be over here in the second quadrant. A straight angle makes the straight line 180 degrees. Okay? Going around all the way to the negative y-axis is 270 degrees. Okay? And all the way around would make 360 degrees, or if you just started, it'd be 0 degrees. Okay. All right, one last concept here, and this is another important one. Because we're going to be doing so much stuff in standard position here on the xy plane, what we want to talk about is what happens when we get large angles. Okay? So, to do that, we're going to use a concept called coterminal angles. So, coterminal angles are angles which differ by 360 degrees. Okay? So if you're familiar with, say, snowboarding or skateboarding tricks, you know that if you did a 180, a 540, or a 900, in each one of these, you'd be landing backwards of where you initially started. Okay? Because all these differ by 360. So again, all these are coterminal, and basically when we look and we draw these out, 180 degrees again takes you here, okay? Whereas 540 just does one extra rotation and then lands in the same exact place. So they really, at the end, they look like the same angle, except one just rotates an extra time around. And 900 would rotate twice around and then again land at the 180 degree position. Okay. Alright, so the final problem is to find the angle of least positive measure, which is coterminal to each one of these angles. Okay. So for 500, okay, again, coterminal angles are angles which differ by 360 degrees. So what we want to do is subtract 360 degrees until we have the least positive measure. For example, if we subtract 360 degrees from 500, we're going to get 140 degrees. Right? Now, if we subtracted another 360 degrees, we're going to get a negative angle. So we don't want to go any farther than that. Okay, so 140 degrees is our coterminal angle there. Okay? Whereas 1,000 degrees, if we subtract 360, okay, we're going to get 640. Okay? And we could subtract another 360, and this is going to take us down to 280. Right? Again, if we subtracted another 360, we would go negative. And again, we want a positive measure, so this is going to be our answer, 280 degrees. Okay. Now, we could subtract, or in this case, we're going to have to add. If we subtract, we're just going to keep going negative. So in this case, we want to just keep adding 360 degrees until we get to a positive angle. So if we add another 360, we're going to get to 320, and this is a positive angle. If we add another 360, we'd still be positive, but we want the least positive number. So this is our least positive number. Right? So to recap, to do a problem like this, all we have to do is keep subtracting if we're already positive 360 until we find the smallest positive number. Okay, the next one we go negative. Okay? Or if we're negative, we just keep adding 360 until the first time we hit a positive number. All right, so that concludes this video on some basic terminology about angles. Right? You should now try your first homework set on angles. Okay, thank you.